Hi, I will tell you about the KLT feature tracking. Feature tracking is used to track the position of an object between images. Here you see the scissor move from image A to image B. What's the feature? The feature at the blue cross is this image patch. The image patch can be used to calculate the partial derivatives. We can then use the partial derivatives to calculate the G gradient matrix, which is a 2x2 matrix. And then we can calculate the eigenvalues. The eigenvalues can be used to determine if the image patch is a suitable feature for tracking. Typically, you use many features to track an object. We use an error function to determine if our estimate is at a good position, the difference between A at the correct position and B, which is our estimate, which will gradually move closer and closer to the correct position by using the vector v. To calculate the vector v, we have to calculate delta I, which is the difference in intensity between A and B at the current position. We have to calculate b bar using delta I and the partial derivatives. We have to calculate n bar, which is a vector which moves us closer to the goal and reduces the error by using the inverse of the G matrix and the B bar vector. We have to iteratively move closer to goal, so we have to loop, and each loop we have to update delta I, B bar, and N bar. If N bar is small enough, we're finished. Otherwise, we update V with N bar and can then use V to calculate B at a new position. I will now show a simple example. Given that we have found our feature A, and we have our estimate position B in the second image, we use A to calculate our partial derivatives. Then we use the partial derivatives to calculate G. Then in our loop we calculate the new position of B. And we calculate delta I, which is the difference between this and this. Then we use delta I to calculate B bar. We use B bar and G to calculate N bar, which is the vector which moves us closer. Then we use N bar to update V bar. V bar is then used to update the position of B in the next loop. And as we iterate again and again, we see that we move closer and closer to our goal. We also see that N bar will get smaller and smaller. And there we found our solution. I will now show a more complex example where we use many feature points to track an object moving in a video. Here we see the scissor move and many feature points getting updated. The blue lines show the direction of the update between the frames. A couple more techniques is being used in this example. We use subpixel accuracy, which means that we can move the B estimate by less than 1 pixel at a time by interpolating between the pixels. We also use pyramiding, which is using multiple sizes of the images. Then you calculate the estimate vector first at the smallest image. Then you use the estimate from this as a starting point for calculating a new in this image, and so forth until the largest and original image, which you get the final result.